I've been playing with this Thorlabs piezo driver, which I picked up on eBay for, I can't remember quite how much, but it was a few $100s, I think. And it was sold as broken, but it seems to work fine. I think they said one of the displays on one of the channels is broken, but I can't find anything wrong with it. There was a screw floating around inside, and it did look like it had been opened, so perhaps that was something to do with it, but generally it seemed fine. Um, anyway, for those who kind of don't know, a piezo driver is basically it's used to drive piezo actuators, and this is a free access driver, so it would be used to drive X, Y, and Z piezo actuators. So piezos are like the things you find in the small round little buzzers that you get in greeting cards or cheap electronics just to make things beep. But the way they work is you apply a voltage to piezoelectric ceramic and it produces a contraction. And that same same kind of technique can be used to make an actuator. So you can actually just move a stage, an X, Y, and Z stage, in free accesses using piezo ceramic stacks, and they're capable of very precise motion, high resolution, and actually quite high speeds as well. So they can move with sub-nanometer. You can get actuators that have sub-nanometer precision, which are used for scanning probe microscopes, for example, which is what I'm interested in. But they need quite high drive voltages, so they're driven with DC voltages, generally up to 150 volts, sometimes as much as 1000 volts. The actuators I've been looking at are 150 volt drive voltage, and that's what this produces. So this takes a 10 volt input and generates a 150 volt output. So it amplifies a 0 to 10 volt input into the range 0 to 150. Piezo actuators can also work with quite high at quite high speeds, so you can travel across the full range at like a few kilohertz. So this has to be reasonably fast. So you get a few microns of travel across the whole actuator range, and you can go up to a few kilohertz. So I was kind of curious to take this apart. It's obviously these are basically designed for scientific labs, and they're quite expensive. So I've been for a really good free access piezo controller. I've been kind of quoted up to £3,000, which I guess is $4,000–5,000. And I think this one would have been probably $1,500 when it's new. So it's kind of curious. I was kind of curious to see what's in it, and as it turns out, it's really quite simple. In some ways, I'd feel a bit ripped off if I paid a few $1,000s for it. Anyway, it's very basic design. Probably pretty much how you would think it would work, I guess, is the first kind of idea. Basically, this is all, the power supplies are all on the right here. So on the top there's a board that produces plus minus 15 volts, and this drives some of the op amps in the system. And then below that is both these boards are driven straight off the mains. So this is a transformer, just steps out, rectifies it, and then regulates it. And on the bottom there's another transformer with I guess a different turns ratio to produce that just throws out like the 150 volts from whatever your supply voltage is. I think this is dual voltage, 120. So yeah, on the bottom there's just another board to do that. So this line here, this red and black wire, is the DC to is the DC 150 volts output, and this is plus minus 15 and background. The actual display stuff is just a bunch of independent modules which it looks like they've bought in, and I think these are just basically voltage meter kind of modules, and then there's a pot underneath it and the BNC input, so that it can, you know, the output can be driven both just by the potentiometer or by a combination of the potentiometer and the BNC input. So you can just manually, you know, set a DC offset basically. And this control part is basically, this is what does all the work. And immediately, obviously, what stands out is these big PA41 Apex ICs, CAN package devices, and they're just basically, I think they're plus minus 300 volt op amps, so they're big, kind of high voltage or reasonably high voltage op amps, and they're quite expensive. So when I've looked around for them, they're on the order of, I think, £50, kind of $100. So I kind of took a bit more of a look at the circuit, and this is all on my blog, which I'll link in the description. But give me a second. Basically, yeah, I have this image on my blog, so you can go and look at it. But basically, it's very simple. These are the three PA41s, one for each channel, and then everything else. These are all pretty much other op amps, which are just OP 27s, and then there's a voltage reference. And I looked at one of the single channels in a bit more detail. And it's, yeah, quite simple. So basically the BNC input, BNC and the pot input come in. The pot is biased with that voltage reference, so that's why that voltage reference is there. That heads into a first op amp, which is basically doing the combining of those, of the BNC and the pots. And it goes into a second op amp, which I guess is a kind of buffer for the PA41. And it heads into the PA41, and that's your output. So very, very simple. I actually have, if I can find it here, I bought a bunch of other stuff at auction recently, and I have no idea what this thing is. It's some kind of, it was with an electrophysiology setup, but it also uses PA08, so I think these are much older actually, op amps, but they have similar kind of voltage range on them. It's called an ion taphoresis pump system, so it's part of that. But I haven't seen anything about these online. But I was kind of thinking of maybe designing a circuit around that part, save me 50 quid for a PA41, and building up, you know, a nice little piezo driver.